Alright, welcome to our Unit 2 review for population. This will also be Chapter 2 in your book. Um, One of the few main things to make sure you kind of understand is population distribution. This is where people are distributed or where they are in the world. So here we're kind of looking for the clusters. There's four main clusters in the world, and there's two kind of secondary main clusters. The big ones to know, South Asia, which is going to be India, East Asia, which is going to be China and Japan, Southeast Asia, which is going to include Malaysia and Indonesia. The two other ones are kind of secondary, but still big clusters in the world, just not as big of a cluster as the other ones. You have Western Africa slash Nigeria is going to be a main cluster, and then the northeast part of the United States is going to be a big cluster. Obviously, there are other clusters around the world, but those are the big ones you kind of want to understand. Again, kind of remember, even in the back of the room, I have that map that shows basically half the world's population is going to be in kind of Asia, southeastern kind of Asia, all kind of combined into one. The final main one that I did not mention is Europe. Keep in mind, Europe is a lot smaller than we kind of think it is, and with the amount of people that they do have there, makes it really, really densely populated. Now, why do we have clustering? Basically, this is the ecumene. This is where people live in the world. Make sure you have a solid understanding of where people live when it comes to kind of physical geography. People really don't live near dry lands. They need water for crops. They don't live near wetlands because it's too much water. Cold lands is just not tolerable to be year in, year out, especially when you think about crops. And then highlands, usually it's too high or too steep to do agriculture, and it's a lot harder to get kind of supplies up and down various hills and mountain ranges. Kind of the big main thing to always know is that most people always live or kind of reside near the ocean kind of coast around the world. Other reasons why you have clustering is culture reasons. Some groups prefer to live in close quarters with each other, not as dispersed. Another one is economic, is another going to be kind of reason why people cluster. Good infrastructure, large markets. So wherever you see large markets, solid infrastructure, people are going to tend to kind of cluster there. Political, people are going to be more and more inclined to cluster in a politically stable environment where you have a friendly government. And then historical is going to be kind of colonization, which we mentioned too before. England or Great Britain, wherever they kind of colonize, you can kind of see there's always been a lot of clustering. Canada, eastern part of the United States, South Africa, Australia, and India. Those are going to be usually a lot of spots that are going to have clustering. That's kind of a leftover thing from the time of colonialism. So now moving on to population density. These are kind of the three main population densities. We're going to look at arithmetic density. That's just your crude density. This is the one you've always known. So it's the number of people divided by the number of land. Number of people divided by the number of land. If you want to make this less dense, okay, just get more square miles, or you have less people. All right. This can be misleading because it doesn't really factor in the quality of the land. It just factors in how much land do you have and how much people do you have. It has no indication of the quality of the farmland that you have. Physiological density, kind of remember physical, and now you're remembering physical land. What is the quality of that physical land that you have? So here we're only taking the arable land, which is going to be farmable land. Remember that arable land is farmable land. So you still have the population with arable land. This is where you're truly kind of measuring the idea of overpopulation. Are you going to have enough resources? Are you going to have enough farmland for your population? A few keys in the world to kind of understand is where you have very high physiological density, where things are going to get a little bit critical. Egypt, especially the Nile River Valley, is going to be one of the few places that have a lot of arable land in Egypt. And then parts of Southeast and Southern Asia will also be up there a little bit as well. Now, there's a number of reasons for this. Obviously, the Sahara Desert, you would think, hey, they don't have a lot of arable land there. How come that's not more dense? Keep in mind that there's not going to be a lot of people that live there. Remember, you don't even have a lot of people that live there. But Egypt, most of their people are kind of clustered along the Nile River Valley because most of the rest of Egypt isn't as farmable or suitable for agriculture. Agriculture density, remember, for agriculture you need arable land and you need farmers. So this is how much farmers you have per arable land. How much farmers you have per arable land. If you have a lot of farmers, it means you don't have as much technology. means you'd need a lot more help to do the farming, and which means most of the people in the society are going to be in agriculture. Whereas the United States, we have a lot of arable land. We don't have as many farmers because we use more industrialized process, more tractors, more technology to do our kind of farming. Now, a few key population statistics you want to always keep in mind. Crude birth rate. Crude birth rate, remember, is just the number of people per year that are born in a certain society or country, and this is by 1,000. So when you have a crude birth rate of 40, it doesn't mean you have 40 for the entire year. It's 40 per thousand. 40 per thousand. This is a good measure of how many people in that society or how many women in that society are having babies per year. Remember, if you're pregnant for 9 months, you're not really likely to have two babies in a year unless you have a baby in January, then maybe again in October and November. So this is going to be one of the factors in natural increase. Again, we have Africa posted here because they do have a lot of very high crude birth rate even today. Patterns around the world, notice the United States is pretty low, Europe is pretty low, but they're also very developed regions of the world. Crude death rate, again, Africa is going to be pretty high in this. So this should give you an indication this is more stage 2. You have higher crude death rate and higher crude birth rate. Obviously, the death rate is falling in these stage 2 countries. They just haven't fallen as fast or as low as stage 3 or stage 4 countries. Now, this is number of people per thousand that are dying in a country. When you factor these two kind of together, you're going to get the natural increase rate or the rate of natural increase. So this is birth minus how many people are dying. Whatever you have left over, that is going to be kind of a raw number. So take, for example, down here, if we had 40 people born in Schulzistan, okay, and then our CDR death rate was 5, so we didn't have a lot of people being or dying, but our birth rate was at 40. That's a pretty high natural increase rate of 35, and that's going to come out to 3.5%. So if you ever see a percentage like a 2.4%, that's actually 24 per thousand. That's 24 per thousand, which would be 2.4%. Remember, the slower or the lower natural increase rate you have, the slower your country is growing. It could still be a pretty big country, it's just growing a little bit slower. Notice United States and China roughly the same amount. We know that China has a lot of people, but the rate of natural increase that they're growing right now has slowed down dramatically over the last few years. Total fertility rate. Do not get this confused with CBR. Total fertility rate is how many babies a woman is having. So CBR is going to kind of measure every woman in the society, how many women are having babies of sorts. And TFR is going to measure how many babies is the woman or that family going to have throughout their lifetime. So this shows us kind of, if the TFR is high right now, we know that they're going to have a huge boom in about 20 years when all those kids decide to have kids and those kids have kids. So this gives us a good indication, kind of a future foresight of the growth of that country. This also tells us about health and contraceptives that are available. If you have a lower total fertility rate, it means contraceptives are available or something possibly different with like women in the workforce, and they're putting off having kids longer in life. If you wait until you're 25 or 30 to have kids, the odds that you have the same amount of kids that if you started with 18 is pretty low. Couple trends to understand is least developed countries or lower developed countries are going to have a higher total fertility rate. Developing countries, this is going to be kind of the stage 3 countries. Notice the TFR is a little bit lower, and then more developed, think about the United States, Japan, England is going to have much lower TFR all the way throughout. So make sure you understand very low developed countries, higher TFR, and this does play a solid role into crude birth rate. It's not an explanation for it, so if you were ever asking why is crude birth rate lower, total fertility rate's lower. Well, why is the TFR lower? All right, what are the factors that make the TFR a little bit lower? Infant mortality rate, this kind of shows us basically healthcare or infrastructure in a society that they have clean water, basic healthcare. When the infant mortality rate goes down, usually you're going to have less and less kids being born in the society as well. So right now we have 60 and above, which doesn't really tell us a lot. It just tells us that it's 60. Sub-Saharan Africa is going to be pretty high. Keep in mind this also does then factor into kind of the crude death rate as well. So once this starts going down, the TFR will start going down and the rate of increase in that country will start to slow down as well. Life expectancy, this is an average. So some of you guys, when you look at the population period, you think they get really, really high, that you say there's a lot of people living to 75, there's a lot of people living to 80. Well, the life expectancy, average age of people in that country, um, when they get older, how long are you expected to live? Now, this changes. When I was born, I was expected to live as a male in the United States, I'm expected to live X number of years. Somebody's born today, they're probably X number of years plus 3 or 4 extra years through their lifetime with better medical conditions throughout their entire life, better social economic factors that come into play. If you have money, you can therefore afford more medical costs. You can have more access to clean water, etc. So kind of notice the trend where we're already kind of seeing more developed regions of the world are going to have a much longer life expectancy than somewhere like sub-Saharan Africa, which is going to be more of a stage 2, more stage 3 type region. Sex ratio. We don't really look at this as kind of a numbers just on paper. Most of the time we look at sex ratio is going to be on the population pyramids, but this is number of males per 100 females in the population. So if there's a sex ratio of 102, it means there's 102 males per 100 females. The sex ratio is 98, it means 98 males per 100 females. So the females always stay kind of the same. Now there are different reasons for this around the world. So why do we have more women here than men in the United States? If everybody lives till their life expectancy, women last a little bit longer. They die of natural causes a little bit later. Whereas you go to China, the reason you're going to have more men than women there is mainly kind of the remnants of that one-child policy act kind of back in the day. The Middle East, possibly a little bit more prevalence of showing males are more taken care of, males have more privileges in society, more of a cultural kind of reason. Whereas China, obviously one-child policy, there was more males being kind of kept alive, obviously culture, but that was more of a government initiative. Dependency ratio. We need to kind of work on dependency ratio, understanding that there's an older dependency ratio and lower dependency ratio. If you ever say there's a high dependency ratio, you're adding in 0 through 14 and above 65. These are people that are dependent on people from the ages of 15 to 64 to work for them, to take care of them, to kind of cover all their financial needs. So usually, again, when you get people over 65, they're going to need more health care. They're going to need Social Security type stuff because they're not going to be working as much. And obviously, 0 to 14, you have to pay for education, you have to pay for schools, and just kids in general are going to be pretty expensive. Doubling time, this is kind of the mathematical one we need to kind of focus on a little bit. This is basically how fast or how many years it takes for your country's population to double based on the current rate of natural increase. This does not mean it's going to happen. Okay, so this is kind of the rule of 70 or the rule of 72. Kind of is this formula. So if you have a rate of natural increase of 2 here, okay, it's going to take 70 divided by 2 is going to be 35. So in 35 years, whatever your population number is now, it should be double that if you keep the same rate of natural increase for those 35 years. Now, if you want to make your rate of natural or your doubling time a little bit longer, like 100 years, that's a little bit better because your population has time to grow. The infrastructure and resources have time to kind of catch up with the population rate as well. If you shrink your doubling time, okay, that's going to be really kind of fast. So if you have a doubling time of 15, that means your population is going to double in 15 years. Think about all the things you need in your country over the next 15 years to kind of help out with those resources that your country or society will need. Schools, jobs, infrastructure, sanitary conditions, healthcare, etc. Replacement rate is going to be 2.1. This is a 100% accurate thing, 2.1. So you can't say it's roughly 2.3, you can't say it's 1.7. Usually when you get to those, that's going to be a huge difference. But this is the total fertility rate, not crude birth rate, total fertility rate. So if women in your country are having a 2.1 total fertility rate, the population growth in your country will be 0. That will be a 0 population growth. And so keep in mind, if we have a woman and a husband, and the woman has 2 kids, both the husband and wife die, now you have 2 more kids, and that female supposedly should have a female, has 2 kids, etc., etc. So you're basically just replacing that people are dying. Again, the point one is we don't have everybody in society living to 70, 80. We have people that die of other reasons, accidents, other natural causes when they're a little bit younger. So if they average 2.1, so basically every 10 couples, if they have 3 kids as opposed to 2, that's going to help our replacement rate stay at 2.1. Now, moving on to the demographic transition model and population pyramids. For this, I'm going to start simply and do all the population pyramids instead of doing pyramids and the DTM kind of next to each other. I think it's going to be a little bit easier. Just make sure you understand this could either be raw numbers down here or it could be a percentage. Usually it's a percentage when you talk about AP type test. Online you're going to find populations. It doesn't matter. These numbers will still be the same because you can easily transfer any of these into percentages of your population. So this is the United States current outlook here. You're going to have males on the left, females on the right. So we have our dependency ratio, which is 65 or above. This is pretty high. This is a huge amount of people that we do have in our dependency ratio. Notice here the baby boomers who are now starting to retire. There's a huge chunk of them that are going to move and shift all the way up here. So they're probably going to trend right about around here. Same thing for the women as well. So our dependency ratio, we will have a little bit of higher, older dependency ratio here in a couple years. So this was a huge baby boom after World War II. A lot of men came back, wanted to have babies with their wives, so we had a lot of babies. Okay, and then after they all had babies, we had a baby bust where people stopped having babies. We didn't need any more babies at that time. And then we had a little bit more, not a baby boom, but a little bit more higher growth. And now over the last 20 to 25 years, with more women in the workplace, more access of contraceptives, you can see that our CBR every year is starting to decline and decline. So I am going to go over this as if you do have a vague understanding of the DTM. So stage 1, there is no stage 1 country in the world. Right, let me repeat, there is no stage 1 country in the entire world. The reason that you do know it's a stage 1 country is if the base is really, really wide, right, but you don't have a lot of people at the top. Usually these are people that are going to die around 50 to kind of 60 here. That's going to be the top life expectancy you could possibly have. Now, when you have one of these kind of pyramids, you're going to have people being born a lot and you're going to have people dying a lot. So you have a lot of people being born, but notice how many people might be dying over and over and over here. Not a lot of if this was the same kind of crude birth rate, notice how many people died. Notice how many people died, and notice how many people died. Stage 2, this is going to be more of, this was the one that you guys had your FRQ on. So this is a classic one. This is going to be kind of the Eiffel Tower one, where you have that kind of more of a waterfall effect to it. So with this kind of waterfall effect, it means you do have people that are now living to kind of a life expectancy age that is going to be pretty common in developed worlds, but you don't have a lot that are living there. But you still have a very, very kind of wide base. And the reason behind this is you still have a declining death rate. So notice that you don't see a lot of huge chunks out of here like you saw in the other one. Okay, we're living a little bit longer. We're not all dying at 50 and 55. Okay, so the death rate is now starting to decline a little bit. Then at the same time, we're still having a lot of babies. We still have a very wide base. Okay, now decreasing growth. This is where we start slowing down a little bit, but we already have that population momentum where we're going to keep going and going and going. Notice that the CBR has kind of stalled out here. So whatever the CBR was, the next year and the year after, it's pretty much the same. Okay. Therefore, that's going to kind of tell us that there's going to be a little bit decreasing of growth. If you see more of a pyramid like you do here, this is a lot of growth, but finally we kind of have this birth kind of thing, CBR, under control. It's a little bit more rounded, but the reason you know it's stage 3 is that it's only kind of straight up until the ages of 25 to kind of 30. Okay, if it was all the way here a little bit, this is going to be a little bit more stage 4. So the mid and upper becomes a little bit wider. Notice here it doesn't have that classic Eiffel Tower look. You do have some width going from the 40s, 50s. People are now prolonging their death a little bit into the 60s and the 70s. Stage 4. Now, just because you have a little indent here doesn't mean it's going to be declining per se, but with this decline, notice now these people are having kids and they have a lower one. But now it's trending lower and lower a little bit. But for the most part, you can kind of see a straight edge here. you can kind of see a straight edge here. The United States would be a perfect example. Denmark, obviously, Denmark is going to have some pronatalism because they can see the future. They notice when these kids get to this age that they're going to have fewer kids and fewer kids. So they're kind of looking way years ahead of the issue they might have with dependency ratio. But also notice how many people are living to the 70s and 80s and 90s in Denmark. All right, with this population pyramid, you know it's stage 4 because you have a lot of people living up there. Now, stage 4 and a stage 5 country, there's no real difference of development. Stage 5 isn't any more fully developed. It's just sometimes with a smaller country, smaller population, they can fluctuate a little bit more. So these larger, older cohorts, you can kind of see for the last 40 years, Germany has trended to having less and less kids, again, more women in the workforce, contraceptives being more available. And it's not going to be a perfect upside down pyramid. You're not going to have a zillion people living to 99, and then you're going to have very few people kind of being born. But if you look right around 50 to 0 and 4 here, you can kind of see that upside down pyramid. Again, people are going to die, and we might have a larger death rate here than you might have in stage 4, only because we're finally getting a lot of these people that had outlived everybody else in the world to now start kind of dying. So the demographic transition model, you can't really see it kind of on my screen here, but this is stage 1, stage 2, stage 3, stage 4, and stage 5. The big thing to keep in mind is the natural increase is nothing that is actually on a demographic transition model. The only two things that go in the demographic transition model are birth rate and death rate. However, the difference between the birth rate and the death rate is going to be the natural increase. So again, the only two things that go into play in the demographic transition model are birth rate and death rate. The natural increase is a consequence or an impact of the birth rate and the death rate. The total population, usually kind of keep this in mind, this follows the natural increase years after. So notice that the natural increase here is getting much bigger here, and we don't really have our population growing until the next stage. So years later, once you start having a lot of babies, a lot of people are living, the next generation, when they have kids, is really when the large growth is going to start to increase on the total population. So again, stage 1, you're going to have almost zero population growth because you're going to have a huge birth rate but a huge death rate. Same thing for stage 4. Okay, you're going to have a very low natural increase rate, but you're going to have a low birth rate, and then you're going to have a low death rate. So keep in mind, stage 1 you have a high birth rate. Stage 2 we haven't figured out birth yet. We're still having a lot of babies. And finally in stage 3 we are starting to have women in the workforce, contraceptives, and birth rates going down. Stage 4, you have even more women in the workforce, more women waiting off and putting off having families until a little bit later, more women in the workforce, etc. Now in stage 2, the big jump in stage 2, and the reason why we have the biggest natural increase in stage 2, notice it carries it for stage 3 a little bit longer, but the biggest gap here is because of the declining death rate. It's not a low death rate, it's a declining death rate. This is still at 13. This is basically sub-Saharan Africa right now. So they have a high birth rate and a very, very kind of declining death rate. All right, but the gap between birth rate and death rate is so large that the rate of natural increase is going to be much larger. So this is going to be like, say, 15 over 40, that's 25, that's a 2.5% natural increase. We're talking almost like 25, 26, 27 year doubling time there. So in 27 years, they keep this up, their population doubles, which means they need twice of everything in their society that they have now. Stage 3, the biggest change in stage 3, obviously death rate continues to decline, but the biggest change in stage 3 is going to be the dropping of the birth rate. Okay? And then stage 4, they decline a little bit lower, and finally we get to almost zero population kind of growth here. It starts to stall out, and then it starts to slowly decline, but that's because you had a lot of older people who are now dying. You're now in stage 5, you're going to have a birth rate that's lower than your death rate, so your rate of natural increase could actually be negative, and that's only going to happen in stage 5. So again, stage 1, you have low growth. You have a lot of people being born, and you have a lot of people dying. Nobody, let me repeat, nobody in the world, no country in the world is in stage 1. You're going to have isolated cases around the world, or isolated villages, societies around the world, but not an entire country. So keep in mind, high birth rate, high death rate. Excuse me. The reason you have fast growth in stage 2, you have a high birth rate and a declining death rate. It's not a low death rate, it's declining. This is going to be sub-Saharan Africa kind of today. Most of Africa, Asia, and Latin America finally got through stage 2 or entered stage 2 because of the medical revolution about 60, 70 years ago when they got very basic medical care in those parts of the world. Now, the United States and North America and Europe, we entered this during the Industrial Revolution, so late 1700s, kind of all the way through the 1850s, during the time of Malthus. So remember, Malthus only saw this stage. So if you think of any Malthus crises type things in your head, all the stage 2 countries are kind of having those fears right now. Now, the growth is now starting to decrease. It's not a negative, but the growth is getting lower. Notice how wide we start from stage 2, and the natural increase starts to settle down here a little bit. Okay, so we have a birth rate eventually around 22. We have a death rate around 10. So now we're growing we have that 10, so that's probably a 1% growth through the years, and now you're looking at a doubling rate of around 70, high 60s. So the biggest change in stage 3 is now you have birth rate dropping. Finally, you have birth rate dropping. Not every woman is in the workforce, not every woman has education, not every woman has contraceptives, but you can see, all right, that is starting to come into effect. You have some of that there. Now in stage 4, it's the same thing as stage 3. You're having a lower death rate, it keeps declining, and then you have a lower birth rate. So you're going to have more of what's going on in stage 3. You're going to have more women in education, more women with contraceptives, all right? But in stage 4, you're going to have really no long-term natural increase. Okay, we're almost kind of at that 2.1 replacement level where you're going to have zero population growth. Okay, everybody who's dying is basically going to replace everybody who was born. So notice here, you're going to have about 12 people born, maybe 11 people born, and 10 people dying. That is going to be roughly zero population growth. Now, stage 5 is kind of this theoretical one, which a lot of newer, or not newer countries, but it's kind of a newer one for us to kind of look at in the last 20 years. Japan, Germany, old Soviet Union countries are now starting to be in this low growth or kind of declining growth. And this is because their CBR, their birth rate, okay, is lower than their death rate. So they have more people dying than more people being born. And we're going to eventually talk about kind of the issues this is going to eventually present countries in the world. So for a quick review of the stages, please remember the only two things that go in this are birth rate and death rate. If you can draw these out, if you can make 5 columns and draw out the birth rate, where is it high, where does it drop down, death rate, where is it high, where does it drop down, okay, and when does it start to level out. If you can draw those 2 things on a piece of paper, almost right away you can instantly tell where the natural increase is the largest, and where it starts to slow down. With that, since we have huge growth kind of right here, okay, after these kids are all born and they eventually have kids, eventually the population starts to get a little bit higher after this kind of generation of huge natural increase. So again, if you can draw out the birth rate and death rate on a blank sheet of paper, just label 5 columns, draw those 2, you can have a good understanding of the DTM. Alright, so now we're on to Malthus and population sustainability. Remember, Malthus is our buddy from England. He was an economist during the Industrial Revolution, which means he only saw stage 2. His conclusion that was basically that the growing population would exceed the carrying capacity, or what basically a country can kind of hold, or an area can hold based on the land that they do have available to them. How many people can a society kind of hold? His basic thing was that he thought there was going to be a population crisis due to famine. We just could not feed the entire world. Keep in mind that he believed the population was going to be geometric, that 1 would turn into 2, and those 2 people would produce 4 people, and those 4 people would produce 8 people, and those 8 people would produce 16 people. This is stage 2 numbers. This is crazy growth. This is really fast. That is why he believed it was going to continue through the 1800s all the way through the 1900s. Excuse me, with population with this J curve. Okay, it was just not going to go steady, it was going to go all the way up, just like a J. Okay, so he thought it was going to go that way. He thought food supply would be only arithmetic. Okay, that you could only over a couple generations make an increase from 1 to 2 crops per field. Now you can go from two sets of crops to 3 sets of crops, or you can have a yield of 4, or you can have a yield of 5, and that this was going to be steady. He could not ever foresee the food supply kind of going a little bit higher with technology, thus raising the carrying capacity. So remember, carrying capacity is where the amount of food supply kind of would meet the population. Anything over this is going to be what we considered overpopulation. Now, did the disaster ever happen? No, because he only saw stage two. He did not see that women would start working, putting off having kids, contraceptives kind of in the future. But he could not assume that the birth rate would eventually slow down. He would only saw high birth rates through his entire life. Most of Europe and North America, we started entering stage three. Therefore, we also started having less kids. Okay, therefore, you're not going to have that huge J curve like we did kind of in the previous slide. The other thing he didn't foresee was technology boosting food production. He did not realize how much technology was really helping the agriculture business at the time, therefore producing more and more crops than we had ever seen in the history of mankind before then. Now we have some neo-Malthusians. Remember, in the 1950s, sub-Saharan Africa, Asia, they had the medical revolution. We thought that was great, awesome. We are making people live a little bit longer, better health care in these parts of the world. And then in the 1960s, people kind of looked at this and said, wait, these people are having a huge population increase. Their natural increase is almost out of control. So they were all stage two kind of warriors. Again, during the last half of the 1900s, people again started worrying about famine. Are we going to have enough food in the world to feed the growing population? Okay, again, they're not really seeing the big picture of stage three coming into play, where you're going to have less and less kids in the world because women will be in the workforce, women will have contraceptives, etc. But these kind of new people that are worrying just like Malthuses are called neo-Malthusans. And then these people are going to kind of bring up this bright idea of having population kind of control policies or programs. Not all of them were as extreme as the ones we kind of learned in class, but you kind of get the idea that they wanted to do something to kind of control the population. Now, their idea is kind of the S curve, where they thought over time the population, this is total population growth here, is going to hit carrying capacity. Okay, but again, they're not going to see kind of the decline or that it's going to kind of level off. They believe that it was going to kind of keep going. So this would be kind of the S curve, kind of the DTM curve over time. So again, they are not entirely incorrect. We do have a finite amount of available clean water in the world. We do have finite amount of coal or energy or oil in the world. So they're not just concerned about food, they're concerned about all the resources in the world. What's going to happen to our population when we don't have enough energy, enough clean water for everybody in the world? Now, some of these main kind of critics to Malthus and kind of neo-Malthusans in general, Esther Bursup, basically, remember, she was a critic, basically saying the more labor we have, the more people we have, the more food we're going to have. And she's going to be very terrible later on in the year when we find out what she wants to do with the land. But she's basically saying if you have 2 people, you're going to have twice as many than you would have of one. So one person can grow X amount of crops, 2 people can grow X times 2 amount of crops. And then the other theory is the cornucopian theory, and this is the idea that technology with more people will bring more ideas. Therefore, this is going to eventually help us solve our food problems. We don't know how they're going to solve them. We just know with more people, you'll have more ideas, more engineers, etc., that are going to help kind of solve this problem in the future. A couple of his other critics, kind of in general for neo-Malthuses, they believe a higher population is going to stimulate economic growth, produce more food in general, kind of like Bursup was saying. With more food demand, it's going to create more jobs. Okay, with more jobs, you're going to have a stronger economy, so it's going to be kind of a cycle here. And then again, for more ideas, more technology, this is kind of a bigger picture for today, where these are more specific kind of criticisms over the years from Malthus. Now with the pro and anti-natalist policies. Remember, natalism is just the idea of birth. So pro-natalist policies, policies that are put into place to have babies, and anti-natalist policies are policies put into place to not have babies for a variety of reasons. Anti-natalism, one of the examples in the book was India. This was more of sterilization. This was really not successful. There was a lot of pushback on this, where people were being forced sterilized. That didn't work, so which led to voluntary sterilization. Again, people don't want to voluntarily get sterilized. Thus, this wasn't really a successful antinatalist policy. One that was a little bit more successful is going to be China's one-child policy. Um, the idea behind China's one-child policy is that every family would have one live birth. As I mentioned in a few classes, it doesn't matter if it's one, two kids, if you have twins, you have triplets, but you would have this one-child policy. Now, with this one-child policy, part of the effects was that families decided to only have males because they were seen more prestigious in their society, so therefore a lot of female babies were aborted during this time. Thus, if you look at China's population pyramid, you look to 30 years, people that are in their 30s and in their 40s, possibly even to their 20s, you're going to have a few more males than you would females. But basically, many women during this time decided to abort their young female babies in favor of waiting to have a male heir, which was kind of deemed these, quote, little emperors. Um, Now, again, China has kind of not released this policy, but they've relaxed it a little bit. More of kind of a two-child policy if you're married. Got to go through a lot of different paperwork, but they've relaxed it a little bit where it's not just one child per family anymore. Now, pronatalist policies usually happen in these stage 5 countries. Japan's a really good example. Down here you have Korea. You can't really see it that well, but you have the 1970s to the 1980s. The TFR, the total fertility rate, women were having 4.5 kids, which is twice the replacement level. Then all of a sudden, right before 1990, they get below the replacement level. And then it continues to decline. So it's not at 2.1. They're not replacing everybody. Now they're down to 1.3, 1.08, and now today 1.24. So they're still about a child behind, or one person behind the full replacement rate that they need. So new policies need to be kind of put into place to spur the growth to replace the people that are no longer working. So when you have all these people in the 50s and the 40s and the 30s leave the workforce, you're going to have huge labor shortage. People need to be able to fill these jobs. Business owners need to fill these jobs. How are they going to do it? And in addition, the thing I think you guys do know very well is that you're going to have a huge healthcare cost for a lot of these older people. The dependency ratio with Social Security type taxes need to be filled as well. So now you're going to have pronatalist policies, or again, the other option is bringing more migrants to help fill these jobs, though Japan's a little bit reluctant to do so. So you're going to have these pronatalist policies. One of them, Russia gives people a day off work to go make babies. Another one is the idea of the Doing It for Denmark campaign, where basically the government's putting out this initiative to just spur people to basically try to have more kids. Singapore has that, quote, national night idea. Singapore is interesting because years ago they were trying to have anti-natalist policies. Now they're having pronatalist policies. So their anti-natalist policies had such a big effect. Then now, with the development of Singapore as a country or a city-state of sorts, they're now entering kind of like stage 4, quickly getting into stage 5, and they see the problem that they're going to have in the future. So they want to start early on these kind of pronatalist policies. Again, keep in mind you need to have about 2.1 babies for total fertility rate for your society. To have like a zero population. So quickly moving on to aging populations. Again, this is only usually happening in more developed countries. So it's not simply, oh, they have a lot of people in the higher end of the pyramid. It's that the average age there is much higher. The average age, so if you take the average age of all these people, right, it's going to be around 45, 50, etc. All right, that's going to be a very high average age for people in an entire country. Again, the generic term for this these are blue zones. A few of the big blue zones in the world: Denmark, Germany, Japan, Finland, are going to be the really kind of big ones that have these older populations. Now, some of the causes of this is that we have much better healthcare, lower infant mortality rate, less spread of diseases. Therefore, we're living longer. Access a steady, healthy supply of food. Just having good food helps us live a little bit longer. So that's a cause of kind of these aging populations. Why are we getting a little bit older in this country? Stable social and political conditions. People are going to tend to live a little bit longer in countries that have stable and political kind of conditions that allow people to have this better healthcare, to have a more stable environment, less wars, etc. And then kind of the final one for this is increased access to birth control. With the increased access to birth control, All right, you're going to have a lower TFR, you're going to have a lower kind of crude birth rate. When you have less kids, therefore the higher older population is going to have much more of a weight, if you can say that, um, on the population average. So therefore, if you're having less kids, those kids are taken out of the average, and you only average in the older amount of people. Now, some of the effects of this: pronatalist policies. Okay, if you know you're having a huge aging population like Japan, they're going to start having pronatalist policies. You're going to have an increase in retirement homes. Society's going to start changing where you're going to be more catering to elderly populations. Whereas you look on TV now, they're definitely still going for the demographics of you guys' age, my age, kind of usually on TV. If we have a really older population here in the United States, we're not going to see commercials for that. We're not going to see advertisements for that. We're not going to see stores for that. We're going to see stores for more elderly people because that's who's going to have the bulk of the money in the United States. Politicians shift their focus to be more friendly to elderly people, kind of going out there saying, hey, we'll take care of Social Security and Medicare. Because you're getting a little bit older, we know you're going to need this, so therefore our politics and our views of older people will shift a little bit. Less people in the working class, therefore you have to have find some way to replace those laborers. How are you going to replace those laborers? The obvious idea is pronatalism, or you can have immigration come into the country, have more migrant workers, therefore you're helping more and more people with that dependency ratio. More money can now be sent to those older people through taxes. Alright, so now we're going on to the ETM. This is going to be kind of a model that was made with the idea of DTM as well. So it's not really separate. It's just an explanation of how people die during those stages, most commonly. This is not a 100% rule. So with this idea here, you have a huge fluctuation in stage 1, a lot of people being born, a lot of people dying. All right, now the reason why you have less people dying in stage 2, or the reason people are dying less in stage 2, or the reason they're dying, is different than why and how people are dying in stage 4 and stage 5. So keep in mind, stage 1, this is where you're going to have a lot of pandemics, a lot of epidemics, and we have no way of kind of stopping this. This is also a lot of environmental factors, hurricanes, storms, disease outbreaks, wild beasts, etc. This is all natural kind of stuff that we kind of have no resistance or no way to kind of defend. The Black Plague is going to be the most common one for this, most common example, because we didn't have any kind of way to stop it. Now, stage 2, where we start having less pandemics. And the reason for this is with basic infrastructure, hospitals, and sewers, we are now able to kind of reduce the amount of pandemics. So they're still dying kind of the same way in stage 2, but with better sanitation, better nutrition, we are now able to put off not having as many epidemics or pandemics. Now, stage 3 is when we see a huge shift. Now we start dying with degenerative diseases. A little bit more developed society, a little bit more stage 3. Now we start living a little bit longer, so we now start dying of cancer and cardiovascular heart disease, which is kind of brought on by a change of lifestyle. We are now able to have more junk food, more disposable income that allows us to live a different kind of lifestyle and probably not as healthy. Now in stage 4, excuse me, we are still dying the same way. We're just dying later. With our improvement in healthcare and the amount of money we can spend on healthcare, we are now able to push death a little bit later. So we're dying the same way as in stage 3. We're just able to put this off a little bit later. Now stage 5, this is more of a new theoretical one. This is more of for only developed kind of countries. This idea of infectious diseases. Now there's 3 reasons why we can now start having more access to diseases, if you will. The first one is disease evolution. Basically, diseases have now built up a resistance to a lot of the treatments we have been giving people over the years. Therefore, it's going to affect people that have been taking this resistance for years. Therefore, it's not as effective anymore, and it's now going to attack more people in more developed countries because throughout the years we could afford that and we had the skills and technology to have that resistance. The other one is poverty. Again, keep in mind, poverty is in every more developed country, there's just going to be pockets of it. And in these pockets, you are now going to start seeing more diseases, etc., because they are the ones that are still kind of like at a lower developed kind of country income of sorts, where they're not going to have as much access to healthcare as everybody else in that society. And then with increased connections, airports, trains, etc., because more developed countries tend to have more money, and we're in stage 5, okay, or stage 4, we are now going to have more interconnections throughout the entire world. Therefore, we have more of a chance to interact with the disease and carry disease and spread a disease much faster than we could possibly have done so 50 or 60 years ago. So, a few main things is keep in mind healthcare around the world. Sierra Leone and West Africa, not going to have really the best kind of facilities. Um, Government expenditures on healthcare. Keep in mind more than 15% of the total government 15% of total government budget in European and North American countries goes to healthcare, whereas in the poor parts of the world, okay, where they probably need the most healthcare, they only have about 5% of their government going to healthcare. And these guys probably have a much bigger budget than these people down here as well. Um, and kind of a good understanding is that government pays more than 70% of all healthcare in developed countries, as opposed to developing countries, private or people on their own must pay more than half. So keep in mind if you're not making a lot in a sub-Saharan African country, keep in mind that you have to take care of a much higher percentage of your healthcare than everybody else in the world.